Hi everyone, it's Michael again. So today I'm going to do a lab walkthrough. So today lab is working with Amazon DynamoDB. For the lab overview and objectives, in this lab you use Amazon DynamoDB to store and manage menu information. Using databases such as DynamoDB simplifies data management because you can easily query, sort, edit, and index data. You will use both the AWS command line interface AWS CLI and the AWS SDK for Python Modo 3 to work with DynamoDB. In upcoming labs, you will use application programming interface API calls from the cafe website to dynamically retrieve and update data that's stored in a DynamoDB table. After completing this lab, you should be able to create a new DynamoDB table, add data to the table, modifying table items based on conditions, query the table, add a global secondary index to the table. When you start the lab, the following resources are already created for you in the AWS account. AWS Cloud 9 Integrated Development Environment IDE instance, Amazon Elastic Compute Cloud, Amazon EC2 instance for authorizing code and running command to the AWS CLI. So here's a pictures of the architecture that what we start with. So here's the AWS Cloud. We have the AWS Cloud 9 IDE. This is the EC2 instance used to authorize, edit Modo 3 Python code, run AWS CLI commands. At the end of this lab, your architecture should going to look like the following example. So here we have the AWS Cloud, we still have the AWS Cloud 9 IDE, we still have the EC2 instance used to author, edit Modo 3 Python code, and run AWS CLI commands. But now we have this DynamoDB right here. That is going to create a table, load data, add index based on the EC2 instruction from here, and then it's going to return data back to the EC2 instance. So this lab is about 90 minutes or an hour and a half. So let's go to the scenario. The cafe website is up and running, and the cafe staff notice a significant increase in new customer visits. Multiple customers also mentioned that it would be helpful if the website had an up to date menu. They could then use the menu to check the availability of food items before going to the cafe. Frank and Martha ask Sophia to explore whether she can implement this feature for customers. Sophia is feeling more confident in her coding skills and has also been learning about different ways to store information in AWS. She knows that before they can dynamically update data on the website, she must first choose a data storage service to hold the data. She also needs to learn how to manage table data, load the product records, and create scripts to retrieve create a script to retrieve information from the data platform. A business request from the cafe. Store menu information in the cloud. Frank and Martha mentioned to Sophia that they want the website to dynamically update its menu information. To prepare for this new functionality, Sophia decides to store this information in DynamoDB. Cafe staff must be able to retrieve information from the table. Sophia decided to create one script that retrieves all inventory items from the table, and another script as a proof of concept that uses a product name to retrieve a single record. For this first challenge, you take on the role of Sophia. You use the AWS CLI and the SDK for Python to configure and create a DynamoDB table, load records into the table, and extract data from the table. So task one, prepare the lab. Before you start this lab, you must import some files and install some packages in the AWS Cloud 9 environment that was prepared for you. So connect to the AWS 9 IDEs and the instruction from the services menu. Search and select Cloud 9. You should see an existing IDE named Cloud9 instance. So we're going to Cloud9 here, and it should create a new instance right here. In the Cloud9 instance pane, we're going to choose Open IDE. The AWS Cloud9 IDE loads in a new browser tab. Open. It's loading. Now download and extract the files that you need for this lab. Run the following command in the same terminal. So this is our terminal. Enter it. Run. Complete it. You should see that the code.zip file was downloaded to the AWS Cloud 9 instance and is now in the left navigation pane. Extracts the files by running the following command. This this action extract the file from code.zip in the environment pane on the left. You should also now see a new folder that is named resources. You use the files that you downloaded and extracted later in this lab. So resources right here. Run a script that updated the version of Python installed on the Cloud9 instance. It will also upgrade the version of the AWS CLI installed to set permissions on the scripts and then run the following command right here. It's running. Let's start running. Afterward, we want to verify the AWS CLI versions and also verify that the SDK for Python is installed. Confirm that the AWS CLI is now at the version 2 by running this command right here. But we have to wait until this installation finishes. Let's run the version. This is version 2. Okay. In the AWS Cloud 9 bash terminal at the bottom of the IDE, we're going to run this command right here. Run the command. Version 2. If you see a message about not using the latest version of pip, ignore the message. So we don't have that message here. Now go to task 2. Creating a DynamoDB table by using the SDK for Python. to store and dynamically manage the cafe menu items, Sophia decides to create a new DynamoDB table. In this task, you take on the role of Sophia to create and define the new Dynamo table. Um, Initially, you create this table with only one attribute because every DynamoDB table requires a primary key. This attribute becomes the primary key for the table. Each value used as a primary key must be unique. The product name is the first attribute that you define in the table. The product name attribute works well because the cafe's product name should not be duplicated. Also, the cafe wants to use the product names to query details about each record. Tips: choose your primary keys carefully. After a table has been created, you cannot change the primary key to use a different attribute or set of attributes. If you must change the primary key, you must create a new table and migrate the table from your existing table. For more details, refer to the Amazon DynamoDB developer guide here. Like the previous lab, you use SDK for Python so that you can use the Python script with the DynamoDB service. So first, verify that no table exists in the environment by using the AWS management console. On the top left corner of AWS Cloud 9 IDE, you're going to choose AWS Cloud 9 icon and choose go to your dashboard. A new tab is going to open in the browser. So AWS Cloud 9 on the top right here, and go to your dashboard. A new tab is open. So in the new tab, open the DynamoDB console by choosing the service menu and then choosing DynamoDB. So in the new tab, open the DynamoDB console by choosing services menu, then choosing DynamoDB. Where is it? In here? This is instances. Services in the new tab. Open the Dynamo console by go services, then choosing DynamoDB. Oh, in the new tab. Are we going to Dynamo? Yep, going to DynamoDB here. Maybe I leave this one right here, but I will open a new tab here and go to DynamoDB. Okay. Note if you see a message that offers a preview for a new console at the top of the page, choose this option. I see messages that offer a preview of the new console at the top of the page, choose these options. Choose the try it and let us know what you think link. Share. This is share, learn more. No, not that one. Note, when the DynamoDB console open, choose any information messages at the top of the page by choose the X in the top right area of the message. Okay. So, on the left, expand DynamoDB navigation pane by this three dot line with this hamburger icon. From the DynamoDB menu, we're going to choose table. table. Okay. And reveal the table pens. It's not in here yet. Notice that no table are listed. What we'll do next is edit the script that will create the table. Return to AWS Cloud 9 IDE browser tab. In the navigation pane of the AWS Cloud 9 IDE, expand Python 3 directory. Expand. Open the create table script by double clicking it. Create table. Okay. Create table.py. Replace fml1 placeholder with the table name, which is this. There's only one right here. So we want to replace this right here with the name, which is this right here. Food product. In the left, upper left, choose file, and then choose save to save your changes. Files, then save. Good. To understand what the script does, review the code. In line that defines the DDB variable, also configure the SDK for Python resources. It sets both the AWS service and the AWS regions that the Python script will call. DDB is set to boto3.resource DynamoDB regions US is 1. The following section provides details that describe the new table. Note of the values of table name, key schema, and attribute definitions. The attribute definitions parameter contain only one value, which is the product name. You can add more attributes later at runtime. The line that defines the table variable also create a table. Boto require key values arguments rather than the object literal format, so you use star params to pass the parameter to create create table operations. Table is set to ddb.create table, passing star params. In the AWS Cloud 9 terminal window, go to Python 3 directory. And run the following code. The code is executing. This command can take several minutes to run because in the code you are waiting for the table to be ready before exiting the function. It might look like it hangs, but be patient. Once the command completes successfully, the terminal output should show the following message: done. So it's done. Once done, and not before, run the following command to make sure the table was successfully created. So it's successfully created, and the output should be similar to following. Now return to the browser tab with the DynamoDB console. Use the refresh icon on the far right. Choose a food product and verify that the table has a created state of active. Yep, it is active. Food product table is active. In the next few tasks, you will learn how to add data to the table that you created. Task 3, working with DynamoDB data, understanding DynamoDB condition expressions. Now that Sophia created the table, she wants to understand that what happens when records are written to it. In this task, you continue as Sophia to insert this first record into the table. Review the JavaScript object notation JSON data that defines the new record. In the AWS Cloud9 IDE, expand the resources folder. Open the not an existing product 5 by double click it. Not an existing product .json. Okay. Analysis. This 5 contains one item with two attributes, product name and product ID. Both of these attributes are string. The primary key product name was defined when the DynamoDB table was created because DynamoDB tables are seamless or schemaless to be exact, not bound by a fixed schema. You can add new attributes to the table when items are inserted or updated. When with DynamoDB, you don't need to change the table definition before you add records that contain additional attributes. So insert the new record. Running the following command ensure that you are still in Python 3 folder. Okay. Verify that the new record was added to the table by using DynamoDB console. To complete the following task, return to DynamoDB console and choose the food product link. Food product link. Okay. Choose explore table item. Explore table item. And then under item returned, review the information. Item return, here's information, best cake. You should find one record with two attributes, product name and product ID. Add a second record to the table. Okay. Let's see. They asked us to add a second record to the table, so I guess we can create an item called item2. Create item. So now we have item2 with no product ID. Okay. Update the JSON data to create a new record. Return to the AWS Cloud9 IDE and load not an existing product JSON file in the text editor. We refresh this. Okay. Replace the product name value of best K with best pie. Okay. Best pie. Do not change the product ID values. On the upper left, choose File and choose Save to save the changes. To add a new record, run the following command. The things I did earlier, right here. Let's see if I can delete this. Nope. Mm. Action. I'm going to delete this item too right here. Refresh this. It should say something. Still bad cake. Add a new record. Where did I save it? There. It says Best Pie now. Go to File, go to Save. So we go to add new record, run the following command. Notice that this command is the same AWS CLI command that you use in the first record. Okay. Again, view the new record in the table by using the console. Return to the item explorer in the DynamoDB console. Item explorer. Go back to item. Explore table item. We still have only one. I guess it's because it's not finished running. Run item explorer in DynamoDB console. Confirm that food product table is selected. Food table. Yes, this is explore the food product. Explore table item. Confirm that food product table is selected. Choose scan and choose run. Choose scan and choose run. Food table right here is selected. Choose scan to run. Yeah. Now we have best pie and best cake. Under items return, review the data. Because the product ID attribute is not the primary key of the table, it doesn't need to be unique, and the new record is inserted successfully if the value of the product name is different. A new record is created in the table. What do you think will happen if you try to insert a duplicate record? It's probably going to have another new record. It's the same thing. Now we're going to return the AWS Cloud 9 IDE and try to rerun the previous AWS CLI command. Let the up key here help. Don't make any changes to the JSON record. And try to rerun the previous AWS CLI. Let's run this. Okay. In the DynamoDB console, choose run again and review the item return list. Do you notice any changes? Run. Nope. Actually, it does not create a new one. When a primary key doesn't exist in the table, DynamoDB put item command insert new items. However, if the primary key already exists, this command replaces the existing record with the new record, removing any previous attributes. This behavior is why you don't see a new item in the table. The record was overridden with identical information. The primary keys prevent the same product name values from being added multiple times. Now try to insert a record with an existing primary key with and a different product ID value. So update the JSON record, return to the AWS Cloud9 IDE, and not an existing product JSON file. Okay. Don't change the value of the product name. Replace the product ID value of 67 to 333. Okay. Save. Run the previous AWS CLI put item command again. I'm going to run this. Oh, that's not how we should do it. Put item, table name, food product, item 5, resource not existing product, region US is 1. Yep, it's the same command here. Let's run it. Now it's run. View the table data in the DynamoDB Explorer, and then by choosing run. Let's choose run. Now Best Buy is have a different product ID. So here's the analysis. The product ID value of Best Buy record was replaced with the new value of product ID. However, you don't want this behavior. You want separate operation for adding new product and for updating product attributes. To implement this feature, you can refine the behavior of the put item command with condition expressions. You can use condition expressions to determine which items should be modified. In this case, you must prevent the record from being overridden if they already exist in the table. The attribute not exist function provides this capability. Next, test the condition expression. You try to insert another versions of the record for Best Buy. Update the JSON record. So return to the AWS Cloud9 IDE and the not an existing product JSON file. Don't change the value of the product name. Replace the product ID of 233 with 222 and save your changes. So in the AWS Cloud9 terminal, run the following command. The command should return this output: an error occurred. Conditional checks fail exception when calling the put item operation. The conditional request failed. This behavior is expected because the condition expression prevented an overwrite of existing item. If you like, you can also make sure the record was unchanged by viewing the data in the DynamoDB console again. Next, you apply what you learn about conditional expressions to working with SDK. Task 4: adding and modifying a single item by using SDK. Sophia now has a good understanding of how to use AWS CLI to control the data that is inserted into the table. She knows that the behavior for inserting data is similar with the SDK. She decides to write to the table by using Python code. In this task, you continue as Sophia to add and modify a single item by using SDK. Update the conditional put.py script in the AWS Cloud9 IDE. Go to Python 3 directory. Open the conditional put.py. Conditional put.py. Conditional put.py. Replace the FMI placeholders as directed in the script. You can also refer to the code analysis in the following step. replace the FMI placeholder as directed in the script. You can also refer to the code analysis in the following step. FMI. You must replace FMI1 with the table name food product. Alright. We'll change this with food product. The second one is apple pie. What is the third one? This one. Have to replace it with this. The fourth one. Number passed in as a string in code. Alright. The 5. Change to is amazing. Okay. 6 is whole pie. 7 is apple. So after that, we're going to save the changes. Save it. Awesome. Review the code to understand what it does. Focus on the definition of the response variable, which begin on line 49. Notice the call to the put item operation in the SDK for Python. The put item operation is equivalent to the put item command in the AWS CLI. The put item SDK operation requires value for item, which defines the record that is inserted into the table. This record contains 5 attributes. Is this? Okay. So in the terminal, we're going to run this file. It's done. If the command completes successfully, the terminal output should give a message done. If you do not see the expected response, review the previous steps as well to see any error and try again. So we will run the DynamoDB Explorer item, and we should get these 3. It's amazing. Get this tag right here. Awesome. In the AWS Cloud 9 IDE, update the conditional put pie script again. This time replace product ID of 8444 with 8555. Let's say the 5. 8444, change to 8555, save the file. Then run the script again. Done. In DynamoDB Item Explorer, review the table data. As you might expect, the item remain unchanged because the condition attribute do not exist. Product name was included in the put item operations. The item was not overridden. This failure behavior is exactly the behavior that you want. What do you think will happen if you change only the product name primary key to cherry pie but keep the same attribute using that conditional expressions? Let's see. So in the AWS Cloud 9 IDE, we will update the conditional put .py script by replacing product name of apple pie with cherry pie. Let's say the 5 apple pie to cherry pie. And then run the following command line again. done. In the DynamoDB item explorer with the review, run this. Now we have cherry pie and apple pie separately. Nice. As expected, a new record was added to the table. Now only new product will be added to the table. This feature prevents accidentally update to existing record when more records are inserted. Now, Taskify added multiple items by using the SDK and batch processing. Sophia is glad that the cafe staff will be able to load individual records into the table. However, she knows that it isn't scalable for cafe staff to load records into the database one at a time. She knows that it's more efficient to use a batch process for loading a large quantity of records at one time. In this task, you continue as Sophia to implement batch processing by using SDK. Because this batch load contains all product records, you must delete all existing records from the table before you run it. In DynamoDB Item Explorer, we're going to refresh the view of the data by choosing run. Okay. Delete all records. Select the checkbox for all the table record. Alright. From the action menu, choose delete item. And then in the pop-up window confirmation box, enter delete and choose delete item. Delete. That's pretty much it. In the Cloud9 IDE, choose resources and choose test.json file and review the data. Resources. Test.json file. Okay. This file contains 6 records that you use to test the batch load script. Notice that this file contains multiple entries for apple pie on purpose. Now update the script that performs the batch load. So update the testing batch put.py script. So in the AWS Cloud9, open Python 3, go to test batch put.py. Python 3. What is it? Test batch put.py. Test batch put.py. Okay. Update the FMI1 placeholder with food product. Replace FMI2 with the product name, primary key name. In the upper left, choose 5, then choose save to save your changes. To understand what the script does, review the code. The table that we'll be reading to by the script is defined in the table variable on line 11. Okay. With the statement that begin on line 12 calls batch writer, which opens the connection to the database. Then the code loop through each record and insert the new data into the food product table. With the statement begin on line 12 calling batch writer, which opened the connection to the database, then 12 batch table. Wait, where are we? To understand what the script does, review the code. Okay. Let's see if these already existed. Right here it's already existed. With table, I think they just want to show us that these already existed. For example, this right here, delete everything. Yep. So in the AWS Cloud 9 terminal, we're going to run the file. Okay. We're adding those food items. After it's complete, the terminal should show these. What is the price in cent value that you expect to find apple pie? Validate your theory by checking the data in the console. So in the DynamoDB item explorer, select food product table and run the scan again. With these three items, this probably the price in cent. Instead of keeping the first value of price in cents for apple pie, the most recent item in the data file was applied. Why did this behavior happen? With a single item put request put item, you can avoid overriding duplicate records by including a condition. However, with batch inserts, you have two options for handling duplicate keys. You can either allow the overwrite or you can cause the entire batch process to fail. Review the test batch put.py script again, focus on line 12. The overwrite by PK product name parameter is included in the batch writer method. This parameter tells DynamoDB to use the last right twins if the right wins if the key already exists. Last right wings is why the price in cent attribute was updated for apple pie. However, you know that the cafe doesn't want the database to add incorrect values for this data set. It's better for the load to fail when duplicate product name values are found instead of allowing the update to add incorrect values. You must change the script so that it fails when duplicates are included in the batch. You can then review and clean up the data. To implement this feature, you remove the overwrite by p keys parameters from the batch writer method. To prepare for the production data load, go to the browser tab with the DynamoDB console and delete all records from the table as you did in the previous step. You can fix the overwrite behavior by updating the test batch put.py script and preparing to load the production data. In the AWS Cloud 9 IDE, we're going to open Python 3 and go to test batch put right here. Update line 12 by changing this right here to the following and saving file. We'll update line 5 by changing this. Where is it? Right here with this line. Alright. It's Python, so what those indentation? Let's see. Now we're going to run the script. Let's run. You will notice error, which is what you want this time. Error. You see any error? Interesting. Doesn't show any error. Oh, I didn't save it. That's why. I have to save it first and run again. Now I have this error. Okay. Okay, so you notice this error. This is what you want this time. The important feedback in this output is a client error. An error occurs validation exception when calling the batch write item operation. Provided list of item keys contain duplicates. In the DynamoDB item explorer, scan the table again and notice that no item has been added at all. Let's see. No, nothing added. This is good. You wish to fail hard and fast if there is a problem. You don't want some item being added and some not. You can leverage this error to catch issues in your JSON data and weed out any duplicate items. Using this fail fast approach, you can now try to load the actual data that the website will use. In the AWS Cloud 9, review the content of the resources website or product.json 5. You will find many items. These items have several attributes and some include an optional integer attribute called specials. In order to load the raw JSON used in the website, you use a new script called batchput.py. It is very similar to the test batchput.py script. This script allows for optional integer special attribute and also maps the names of more fields to the correct DynamoDB attribute type. Now we're going to modify the Python 3 batch.py script. So replace batch.py. We go batch.py right here. Let's see. So we're going to replace mfi with food product. Okay, that's only mfi. And of course have to save it first. Now we run the script again. Python batch.py is going to add different item. After script complete, the terminal should show the following outputs right here, which we had. So in the terminal in the DynamoDB item explorer, when we reveal the inserted data, we're going to see C26 item. The image below is a truncated image for brevity. Run it. We'll see a bunch. 27 in this one. Added 26. Okay. Task 6 is query the table by using the SDK. Now that the data is loaded, Sophia needs a way to retrieve or query the product information from the DynamoDB table. The SDK has two operations for retrieving data from the DynamoDB table: scan and query. The scan operation reads all the records in the table, and unwanted data can then be filtered out. If only a subset of the table data is needed, the query operation often provides better performance because it reads only a subset of the records in the table or index. Frank and Martha want to show all the menu items on the cafe website, so Sophia decided to use the scan operation to retrieve all records from the table. In this task, you continue as Sophia to implement this feature. Note that later in the application development process, you use this Python code in the AWS Lambda function. The Lambda function retrieves the table records so that the cafe website can display all the pastries. Next, we're going to edit the script that select all the record from the table. In the AWS Cloud 9 IDEs, we're going to open Python 3. We go to get all items. No, do not use get all item 5 in the resources folder. Yep, we're going to use Python 3 right here. Replace mfi1 placeholder with food product table name. mfi display it with food product, and then we want to save it. Review get all item py script to understand what it does. So on line 15, the scan operation is defined in the response variable. Notice the while loop that begin on line 18. If the result of the scan operation is large, DynamoDB split the result into 1 megabyte chunks of information or the first 25 items. If their total is less than 1 megabyte, these chunks of returned data are called pages. When while loop run, the code processes each page. This is also known as pagination. The loop then append the record on the end of the result set until all data has been received. So we have response, the data scan, data response item, while response is get, the last evaluate key will response scan exclusive start key, response, last evaluate key, data extend, response to item. So in the AWS Cloud 9 terminal, we're going to run the script. Okay. So the return data should be something similar to this output right here, an array of objects. So notice that Python return a numeric data in price in cent, attribute as decimal, number as string. This is not valid JSON, but that's okay for now. You address these issues in future lab. You have a good start with this query, which return records. However, you want to try and search based on a attribute so that Frank and Martha could query for a specific product if they want to buy using the product name. You decide as a proof of concept to create a new script that return a single product instead of returning our product. We go to update get one item pie script. Get one item pie script. Get one item pie script. We're going to replace everyone with the name of the table primary key. Replace fi1 with the table's primary key. Right here. Wait, what? Primary key. Where is the primary key? We just with table primary keys import key. With the does that mean I want to put key in here? Import button from import key. Let's see if I just replace the whole thing with key, then save it. Review the code to understand what it does. So focus on line 13 and 14, which define the response variable. The get item operation require a table name and a key. The key parameter for 13 and 14, 13 and 14 right here. So we have it right here, 13 and 14. Okay. The get item operation requires table name and a key. The key parameter is used to compare the table primary key product name with the values that is passed in from the main modules of the script. On line 24, note the values that assigned to the product's variable. Also observe that this value is passed to the get one item functions. Note that the get item operations is higher level abstraction of the query operation. It is designed to return a single item. In the AWS Cloud 9 terminal, we want to run this command right here. Let's check it. Let's see. If it's successful, so we run on this. So I guess I can go back and response key to product name will be a string. Oh, similar to what this sounds. So I'm gonna run this command again. Nope. Hmm. Let's see. Wait, where is it? Right here. Table name, food product, key. Should I change the product name? Right, product name as product. Soon it's run. Oh, have to save it first. Did I save it? Save it. Run again. Okay, now we got it. Awesome. If the script completes successfully, the output should be similar as following example right here. And you will notice that this is now in the DynamoDB objects format, unlike the query you did before, and thus includes keys such as N and S. This is fine for now. You could parse that out and turn it into JSON that the website can understand using Lambda. However, this feature was only for a proof of concept. Sophia demonstrated the database features that she developed for the website to Frank, Martha, and the cafe staff. They are pleased with the website. Will soon be able to show all the live product information instead of the hard-coded version that they have currently. Task 7. Adding a global secondary index to the table. Frank and Martha like the proof of concept that can now query the database for a specific product, but return to Sophia with a request for slightly more useful features. The cafe staff originally thought that they would like to list all the product when the main page loads, but loading all 26 images would slow down the website. They consider a pagination features, but with only 26 items, this option feels unnecessary. Instead, they have asked Sophia to expand on the proof of concept that search based on the product name. This time, they need to search for items that are both part of the weekly specials and also show that they are on offer in the tag attribute. This way, when the website default page loads, it fetches only the feature menu item. You can also give the user the option to show all items when building the website. This option makes the website much more efficient. You make these website changes in a later lab to accommodate this new loading process. Sophia knows that searching on a primary key is easy as per proof of concept. However, in order to search on attributes that are not part of a primary key, she needs to add a global secondary index to the existing food product table. In this task, you continue as Sophia to implement this feature. To change to change the characteristic of a table, such as adding an index, you must use the update table operations. For more information on this operation, refer to this. Now we're going to update the add GSI py script. Add GSI py script. We're going to replace fm1 with the key type of hash. Okay. Now save. To understand that the GSI py script what it does, then open the script to review the code. So we review the param variable on Lightel. Focus on the global secondary index updates parameter. Notice that a new index named special CSI is created. This new index consists of one attribute specials. Similarly to the table creation, the line that defines the table variable also update the table. So we have this code right here, params table name, attributes definition, global secondary index update, create index names, key schema, attributes name, key type, projection type, so on. So in the terminal, we're going to run this command. And if the command successfully, the terminal should output the message done. It can take up to 5 minutes for index to populate. So in the DynamoDB console, monitor the status of the index. So choose table, DynamoDB console. We go back to DynamoDB. Choose table. Choose food product. Choose indices tab. Okay. Wait until the status changes from creating to active. Creating. We're going to wait until it say active. See, refresh. It's still creating. Tell us to wait until status change from creating to active. It should be like this. Note that if you are using a new console, the status column might become hidden a few minutes after the index creation and population has completed. This special GSI index is a sparse index, meaning it does not have as many items as the main table. It is a subset of the data and it's more efficient to scan when you want to find only the items that are part of the specials menu. Still creating. Okay, so update the scan with filter pi. I guess I'll still wait until where is it? Right here. I'll wait until say active. Still creating right here. I guess we just wait a few more minutes until it's say active before moving on to the next step. Let's see, auto scaling off here, read capacity, write capacity, auto scaling is also off. Refresh is still creating. The next step we should what we should do is update the scan with filter pi. Scan with filter pi right here. For scan with filter pi script, you're going to change FMI1 to special GSI. Special GSI. FM2 with the name to tag. Change this to tag. Reviewed. File save. This one is still creating. On line 18, including index name option, let the scan operator know that it We're going to the index and not the main table to read the data. On line 19, the filter expression processes the record that have been read and show only records that meet the comparison criteria. In this case, it shows record only if they don't have the out of stock in the tags attribute. This ensures that only items that are available or on offer are shown to the customer. So respond, data scan, index name, special GSI, filter expression, not attribute tag, contain out of stock. Note that you may be familiar with the older DynamoDB parameter scan filter. This is a legacy parameter. Filter expression should be used instead. Filter expression does not include all the operators that were provided with a scan filter. For example, not contains. This is why you grab the comparisons inside the not function. Okay, go here. What I'm going to do is save it, and then I'm going to run this file. The output should be that special GSI. The special GSI still, so because it's still creating, so that's why I'm not able to um, run the code here with if we run the special GSI just yet. But like after it's finished creating, I should have the output of the following right here. So again, the response is not in the format the website requires. However, you can use this code in the Lambda function in later lab. You will adjust then. So update from the cafe. Sophia is happy with the process that she has made. Database table is loaded with data. She addressed the cafe database backend requirement, and she will soon wire this into the website. Sophia next task is to create an API that the website can use. Sophia decided to stop for the day, so she's looking forward for her next task. She plans to start working on creating a mock API that she can use for testing. And that is it for this lab. Thank you so much for watching and have a great day. Bye bye.